A network of 9 conductors connects 6 points A, B, C, D, E and F as shown in the figure. The figure denotes the resistance in ohm. Find the equivalent resistance between A and D. Before I find out the equivalent resistance, let me redraw this diagram. This point will be equal to A. This point is D. There is another point which is equal to E. Okay. There is another point which is equal to F. Okay. So the resistance are 1 ohm, 1 ohm and 1 ohm. And on the outer periphery, there will be a resistance of 1 ohm. Okay. This is connected to point B. Okay. This is connected to point B. And there is another resistance of 2 ohms connected over here. And there is a 1 ohm resistance between this point. Okay. There is a 2 ohm resistance along this part. Okay. So if I connect it, this will be equal to 1 ohms. Okay. So this is the entire diagram over here. Okay. Now first of all I have to find out between A and D. So I will apply, you can clearly see over here, a folding symmetry. Okay. Before I apply the folding symmetry, I can say that on the left hand side as well as on the right hand side, the given circuit is same on the left as well as the right hand side. Okay. So I can say that from point D, E and F are at equipotential, are at equal potential. From point A, B and C are at equal potential. Okay. Now let us concentrate first on E and F. If E and F are at equal potential, I will eliminate this given resistance. Okay. This resistance won't be in the picture. Okay. And if B and C are at equal potential, I can eliminate this resistance. Okay. So if I redraw the diagram, there will be point A. Let me draw a point D over here. Okay. And let me plot the B. So I can say that B and C are at equal potential, so it will be equal to B comma C, and E and F are at equal potential, so it is equal to E comma F. Okay. So let me draw the given resistors, okay, between point A and D, between point B and C, and D and E and so on. Okay. So E and F are at equal potential. Okay. So first of all, between A and D there is one 2 ohm resistance. Okay. So I will connect it somewhere over here. Between point A and D there will be a 2 ohm resistance over here. Okay. So between point A and D there will be a 2 ohm resistance. Okay. Between point A and B and A and C there are two resistance of 1 ohm and 1 ohm. Since both of them are at equal potential, I can say that there is 1 ohm over here and there is 1 ohm at the bottom. Okay. 1 ohm at the bottom. Okay. Between B and C and E and F, between B, C and E, F, okay, B and E, there are two resistance of 2 ohm and 2 ohm. Okay. Both of them are in parallel. Okay. Both of them are in parallel, which is equal to 2 ohm over here, and there is a 2 ohm resistance in parallel. Okay. Between point F and D, between point E and F and D, there are two resistance of 1 ohm and 1 ohm. Okay, which I will write it like this. Okay, this is 1 ohm and there is 1 ohm in parallel. Okay, so this is the equivalent circuit. Now in order to solve this equivalent circuit, both these resistance are in parallel, so it will give me the equivalent resistance as half. Both these are in parallel, so it will give me 1. Okay, 1 by 2 plus 1 by 2 will be equal to 1. And both these are in parallel, so it will again give me half. Okay, so half, 1 and 2. Now the resistance will look somewhat like this. Okay, this is a half ohm resistance, this is a 1 ohm resistance, this is equal to half ohm resistance over here. Okay, and to this in parallel there will be a 2 ohm resistance. Okay, there will be A and this point will be over here, B will be equal to B. So half plus 1 plus half will give me the answer as 2. This in parallel will give me answer as 2. 2 in parallel to 2 will give me a equivalent resistance as 1. So R equivalent over here will be equal to 1 ohm. This will be the equivalent resistance for the given circuit.